Welcome back everyone, Patrick here. Moving on to the next question. This is a pretty cool one, pretty unique one. So we have to find the missing values for A, B, C, H, and or K in each of these over here. So notice that they're equations. So what they're saying is like this quadratic, x squared plus 10x plus c is equal to this quadratic, x plus h squared, etc. etc. And so we have to find, for example, in this one, the c value and then the h value that would make both of these quadratics equivalent. Or for b, we have to find this b value and then this h value that would make them equivalent, or this b and c, etc., etc. So the way that personally I would do this is I would match up the formats of both sides, because notice that, for example, here in part A, we got standard form on the left side, but then over here we have factored form. Actually, this is also vertex form. Whenever you got some quadratic that is like this is factored form, but it's also technically vertex form because there's like a +0 over here. I've mentioned this in previous units when we were first getting into the format. So something like this is actually both formats, but nevertheless, the format on the right side is different than the format on the left side. That's the point here. And so you want to make them be both formats, and then you could start solving things. Here we got standard form, vertex form, standard form, vertex form. So you got to pick one of the formats, and in my opinion, the easiest one to work with this kind of question is standard form for both the left side and the right side. So for part A, we already have the left side in standard form, so let's write that. But then this this right side we don't have in standard form. So what I would do is I would expand it so we can convert it to standard form, and then these two are like terms. So we'll have x squared plus 2xh plus h squared. So if we take this, convert it to standard form, we'd end up with this. And so here we could take this and put it right there. We'll have x squared plus 2xh plus h squared, like that. And now what you can do is you could basically just match up the coefficients. So notice that the 1 over here, that's the same as that one. So that makes sense. Notice here, the coefficient, the b coefficient, let's actually rewrite this instead of 2xh, let's write it as 2hx. Notice here the coefficient is 2h. Over here, the coefficient is 10. So we can make an equation there. We could say 10 has to equal 2h. Right? Both of these are the b coefficient in that standard form. And then the other, plus c, is equal to plus h squared, like that. And so how would we work this? It's kind of like a puzzle. You got to figure out where can we solve for something. Well, notice we could solve for the h here, right? We could divide both sides by 2, and we'd get an h value of 5. So that would give us an h value of 5. And then notice we could find the c value, because we know what the h value is. We could plug it in there. That would be 5 squared. So c would be 25. And that's the answer for part A. So for part A, h value of 5, and then a c value of 25. And then if you have the time, you can actually plug those in and check your answer. So if we plug in that c value on the left side, we'd end up with x squared plus 10x plus 25. If we plug in that h value over here, we'd end up with x plus 5 squared. If we expand that, x plus 5 times x plus 5, we'd end up with x squared plus 5x plus 5x plus 25, x squared plus 10x plus 25. Notice left side would be the same as the right side. So you could always check your answer with these kinds of questions. Okay, so again, get them in the same format. Doesn't necessarily have to be standard form, but I do think it's a lot easier to put everything in standard form. And then just match up the coefficients, see what you could solve for, and then solve for the other variables. So let's try the same thing, but with part B. So notice that the right side, in this case, is going to expand to the same thing. And so we could just say x squared plus bx plus 49 is equal to, when we expanded this, this was x squared plus 2hx plus h squared, like that. And so 1 and 1, can't do anything there, but then notice we got a b, the plus b over here has to equal the plus 2h right there. And then we got the 49 has to equal the h squared. So we'll go h squared equals 49. So where can we solve for something? Well, over here we got two unknowns, only one equation, can't do that. But over here, notice we could say h is equal to the square root of 49. And actually here there's going to be two potential answers. H can be plus or minus 7. So if h is positive 7, for that case, if we plug in 7 over here, 2 times 7, the b value would be 14. And then if h is negative 7, then the b value would be negative 14. So we got two potential solutions for part B. And again, you could take these, plug them in, expand them. You'll see that the left side is equal to the right side. So for part B, we could either have h equaling 7 or b equaling positive 14. Or here we can have h equaling negative 7, b equaling negative 14. Right? This has to be a perfect square trinomial. We've done questions like this, similar ones, when we're dealing with perfect square trinomials. Not all of these are going to be perfect square trinomials, as you could see with parts C and D. But for those ones, those are what the different solutions are. Let's move on to part C. So we got x squared plus bx plus c. So notice we got two unknowns in this case. So that's already in standard form. Let's take this vertex form and expand it and put that in standard form. So when you expand this, when you FOIL everything out, you'd end up with x squared minus 8x plus 16. Then you got the plus 7. X squared minus 8x. These are like terms over here. That would give us 23. So now we can match up this left side. We got x squared plus bx plus c. Let's match it up with this right side, and it matches just directly. So we could tell the b value is just negative 8. We could tell the c value is just 23. Right? But there's no algebra that's required in this case. Okay, so here the b value is negative 8. The c value is positive 23. And those are the only two unknowns over here. So that one was pretty simple. I think part D is going to be a little bit more complex because there's actually an unknown on this side. Here there wasn't, but here there's going to be, and then we have two unknowns here. So this left side's already in standard form. This we have to convert x minus h times x minus h. Let's do this in steps. So let's first multiply the brackets. We end up with that right there. And then notice we end up with these netting out like that. And then what we could do, we could distribute the 3 inside the bracket. So we'd end up with 3x squared minus 6. I'm going to put the x in front, so we'll have 6hx. And then we'll have plus 3h squared plus 4, like that. And that's actually in standard form. If you notice, we'll have ax squared plus bx plus c. This entire thing right there is the c value, because h is going to be some kind of number. It's not a variable, right? X is the variable. So the a value is this, the b value is this negative 6h, the c value is that entire expression right there. So that's the more tricky part. So let's actually match these up now. We'll have ax squared plus 12x plus c equals 3x squared minus 6hx plus 3h squared plus 4. like that. So from here, matching them up, notice the A value, it's just equal to 3, which is nice. We just get it directly. But then the rest, I think we're going to have to do some algebra. So notice the B value here is positive 12. What's the B value here? It's the negative 6H. And then notice that the C value, it's equal to this entire thing, as I mentioned before. So it ends up being that. Okay, so we got two unknowns, two equations. We could solve for the H value over here. That's what's easiest to do. So we could divide both sides by negative 6. So H would be negative 2. And then we could plug in this H value there to get the C value. Right, so as I mentioned, it's kind of like a puzzle. You got to sort of line everything up and then see what you can solve for. Every question is going to be different with what you can solve or what order things solve in. Multiply, then add. That would give us, what, 16? So C is 16. So those end up being our unknowns for this over here. And again, if you have the time, you can check your answer. So let's check it for this last one. So the A value we got was 3. So we got 3x squared plus 12x plus the C value, which is 16. And then we got 3. What was the H value we got? It was negative 2, right? So here you got to be careful because we got x minus the H value. The H value we got was negative 2. So we got plus 4. So you're subtracting negative 2 over here. So, sorry, I forgot this exponent. So these here, this would end up being 3x plus 2 squared plus 4, right? And so what you want to do, this is already in standard form. Let's expand this and see if we get that. We'd end up with 3. Now x plus 2 times x plus 2, that would give us x squared plus 4x plus 4. And then we'd have plus 4. Then you distribute that 3 inside the bracket. 3x squared plus 12x. 3 times 4 is 12, plus 4 would give us 16. So notice that they indeed would be the same, right? So an A value of 3, a C value of 16, and then an H value of negative 2 for this equation would make both quadratics equivalent.